Hey y'all, this is lesson 8.6, the last one in Unit 8, and it is all about percent yield. Um, Basically, the deal with percent yield is that nothing is perfect. So no system of anything is 100% perfect, right? If you are making whatever, it doesn't matter. There is usually some sort of loss because the system isn't 100% efficient. Like if you're making, we'll say you're making brownies or cake or something like that, and you think about it, like some of the cake mix sticks to the bowl, sticks to the spoon. So your cake it won't exactly weigh what your ingredients did because there's some loss. Like I said, it sticks to the bowl, or you take a spoonful of it and eat it, even though with raw eggs, that's bad. You shouldn't do that. But I must admit, sometimes I do too. Um, or back to our s'mores, like some of the marshmallow sticks to the stick that you use um, to roast it, or one of your graham crackers breaks, and so you throw it away. Right? Um, so nothing is 100% efficient. Right? There's always some loss. And so, what percent yield is, it calculates how much of the product was actually made versus theoretically how much could have been made. Um, but there's always, like I said, some that gets wasted, some that gets lost for whatever reason, um, spilled, damaged, uh, all sorts of different reasons. So your dog sneaks up and eats one of the graham crackers, then you can make less s'mores, right? Because you're missing some of your ingredients. So what the percent yield will tell us, whether we're cooking or as a scientist or whatever, is how good our system is, right? If you can get a high percent yield, you can save some money, right? If you get a low percent yield, a lot of that goes to waste. Then you don't have enough product to sell and whatnot, and so you won't make as much money. And so you that loss can be really damaging. So you want your percent yield to be high. That shows how efficient your system is. Okay, so let's do some example problems of how that works. So here's our problem. Here it says you start building s'mores using the ingredients, right? You have an excess of graham crackers, so you got plenty of those. Got an excess of marshmallows, plenty of those. Only 275 squares of chocolate. At the end of your s'more making, you realize that you have mysteriously only produced 250 s'mores. Calculate your percent yield. So some of that chocolate was lost, whether someone came along and ate it, or it dropped on the ground and you had to throw it away, or it melted. For whatever reason, you didn't make as many s'mores as you could have, right? So, what's your percent yield? How efficient, how effective were you at making these s'mores? Here's the process. First, even though we can do this in our head, let's practice. You need to calculate the predicted amount of product, right? So, we go back to our ratio, we go back to our equation, remember, which was 2 graham crackers, 1 chocolate square, 1 marshmallow makes 1 s'more, right? So, in order to calculate our predicted amount of product, we need to get that ratio, which is 1 s'more, 1 piece of chocolate, right? That's the ratio. 1 s'more, 1 piece of chocolate. Okay. So then we're going to calculate the amount of product that it is possible to make with what we have. We have 275 squares of chocolate. The ratio is 1 s'more, CHM, from 1 square of chocolate. So multiply, divide, all those are ones, so that's really easy. We should have been able to make 275 s'mores, right? So theoretically, we should have made 275. We only made 250. For whatever reason, we lost 25 squares of chocolate somehow. So we couldn't make as many s'mores, right? So now we need to calculate our percent yield. Here is the equation. Our actual yield, what we actually got, divided by theoretically what we should have been able to get, times 100. Same equation for any percent you want to do. You want to figure out your grade, the actual number of questions you got right, divided by how many questions you could have gotten right, times 100, grade. All right, so percent always works the same way. What you actually did, what you could have done, times 100. All right, so for our s'mores, our actual yield was 250. Theoretically, we should have been able to get 275. When you divide this and multiply it by 100, that is 90.9%. So we were 90.9% efficient. Not too bad. If we're just talking about grades, it's still an A, barely. But not horrible. Okay. So that's our percent yield. Let's try it with our ammonia. Okay. So we'll remember our equation for ammonia. 1 mole of nitrogen plus 3 moles of hydrogen made 2 moles of ammonia. Okay. So here we go. Our scientist performs a reaction. Excess of nitrogen, so we don't care about that. 200 grams of hydrogen. He produced only 751 grams of ammonia. What's his percent yield? How efficient was he? Do we need to fire him because he's losing us money because for whatever reason he's not getting enough product? Like, maybe that's our job. It's time for his evaluation. You stink at doing this. You don't make enough. Your percent is very low. I don't know. Whatever. Let's figure it out. First, just like before, calculate the predicted amount. Here's our ratio. The desired product, 2 moles of ammonia. We're looking at hydrogen, so that's 3 moles of hydrogen is our reactant. So 2 ammonias from 3 hydrogens. Okay? Next, we're going to figure out our predicted or our theoretical amount of product. Okay, so what we're given is 200 grams of hydrogen. Our molar mass of hydrogen is, remember, in 1 mole, there are 2 grams, 1 for each hydrogen. So these units are going to cancel. Here's my ratio from right here. 2 ammonias from 3 hydrogens. Yeah, because this is 1 mole of hydrogen. And then my last molar mass, which is my ammonia. Remember, that's 14 for the nitrogen and 3 for 3 hydrogen, so 15, 16, 17. So it's 17 grams of ammonia in 1 mole of ammonia. So my moles of hydrogen cancel, my moles of ammonia cancel. I'm left with grams of ammonia. And I do all my multiplying and dividing. And I end up with, theoretically, I should have been able to make 1,130 grams of ammonia. That's how much I should make. This guy only made 751 grams. So let's see how well he did. I'm thinking not very good. Remember, here's my equation. My actual yield, how much he actually made, was 751 grams. How much he should have been able to make, 1,130 grams times 100. We figure all this out. 66.5%. Not very good. So for some reason, there is some loss. Whether he is spilling something or he is not doing it right or the process. Maybe there's something wrong with the process and he's doing the best he can, but at some point in the process, there's something goes wrong, right? And it might not even be his fault, but we have to look through and see where, because this is bad. And we should be able to make more than this, right? Um, so there should be something we can do, whether it's fire the scientist because they're just not doing a good enough job, or something's wrong with the system. Let's try to fix it. We know things aren't perfect, but like it says here, because things are expensive and you want to get the most you can out of it, this will make you go back and look and say, okay, where could this process be better?